This is one of a series of videos on sketching trigonometric functions, and this one is looking at the horizontal translation of what's known as a phase shift. So we're going to start with just looking at a phase shift, nothing else. And again, our first step is always the same. It's a sine curve. What does your basic sine curve look like? It starts at 0, 0, up and down, okay? We know there's no amplitude change. There is nothing out the front. Okay, so our amplitude is going to be the standard 1. So our graph's going to go from -1 to 1. Moving along, there is nothing happening in front of the x, so our period remains as per the standard, which is 2 pi. And our axis is going to be the standard pi on 2, pi, 3 pi on 2, and 2 pi. Okay, so now we have the horizontal translation, or the technical term for it, the phase shift. And that's what's happening in these brackets. It's no different to your other translations. Because it's a minus pi on 4, it's going to move to the right. Okay, so moves right pi on 4. And I recommend when drawing your graph, deal with this last. Okay, so we're going to draw our graph with everything else but that horizontal translation, which basically means we're drawing our standard sine graph. So let's start with our axes. Okay, so we've got our axes, label them, put in 1, 2, 3, 4, pi on 2, pi, 3 pi on 2, and 2 pi. Your amplitude is 1. It's just standard sine curve. Again, if it helps, draw in a bit of a grid so you can get your graph as accurate as possible. Yes, it's a sketch, but we still want it to look accurate. Okay, so sine curve. So we start at the bottom at 0, 0 and put in those basic dots. So when you're looking at this basic curve, you can see where those dots are. Now, don't just draw a little sketch. This is not your final curve. So just light with your pencil, drawing in that curve. So this curve is y equals sine of x, but we need to take our translation into account, which is moving right pi on 4. Now pi on 4 is half of pi on 2. So all of these dots that we had are going to move to the right pi on 4. Now we want to get our scale right. So if we're starting at pi on 4, we go 2 pi on 4. I know people struggle with fractions, so let's make sure we nail this. So you just keep going up by pi on 4 to get that scale. 8 pi on 4 is your 2 pi, but I'm going to go one more because I know I'm translating to the right. Simplify the fractions that you can. And then put in that scale. So now I have pi on 4, my 3 pi on 4, 5 pi on 4, 7 pi on 4, and my 9 pi on 4. Translate each of the dots to the right pi on 4. So each of those basic dots you had before is going to move to the right pi on 4. Join your new dots. I'm just going to extend this line down a bit, put an arrow, label y equals sine x minus pi on 4. Now, if we needed, it does just say showing one complete cycle, which we've done. If they wanted our y-intercept, which is a key point, that's when x equals 0. So y would be sine of 0 minus pi on 4, which is sine of negative pi on 4. So you're in your fourth quadrant. Sine is going to be negative. So that's negative sine of pi on 4. And sine of pi on 4 is 1 on root 2. So you negative 1 on root 2. And getting that as an approximate, it's approximately negative 0.71. So if I needed to extend this curve down, I know that that point there is negative 1 on root 2. And I could put in my y-intercept. Okay, let's look at one more. Now this one brings in a few more aspects. You've got your amplitude, and you also, the amplitude at the front, you've also got these 3 happening here that we're going to have to take into account. Okay, so basic cos curve starts at the top, goes up. Okay, amplitude equals 2, so we're going to go from negative 2 to 2. I need to factorize that 3 out, so it becomes y equals 2 cos 3 bracket x plus pi on 3. So this 3 here is going to be for my period, and the plus pi on 3 here is my phase shift. So period is going to be 2 pi over 3. We need to divide that by 4. So we have 2 pi over 12, which is pi on 6. So our x-axis scale is going to be pi on 6, 2 pi on 6, 3 pi on 6, 4 pi on 6. That's pi on 3. That's pi on 2. And that is 2 pi on 3. Okay. Last thing is our horizontal translation, which we're not going to worry about until the end. It's a plus pi on 3, so it's going to move left pi on 3 radians. But again, we're going to deal with that last. So go and draw your axes, label your axes, put in your 4 points on your x scale, which we always do. That's from dividing our period into 4, so pi on 6, pi on 3, pi on 2, 2 pi on 3. Our amplitude is 2. That's going to be between 2 and negative 2. And we're just going to start with our standard curve without that phase shift. So everything else up until the phase shift. It's a cos curve, so we start at the top, down, down, up, up. Again, just draw it in lightly. It's not your final curve. It's just getting you there. Now, our horizontal translation was to the left, pi on 3. So 2 graduations on this x-axis is equal to pi on 3, which you can see there. So what I'm going to do is I'm going to extend my x-axis in the negative direction, negative pi on 6, negative pi on 3. So I can move this curve back. Okay, and when I draw this arrow up here, I'm going to change that. So I'm going to do from this point to that point, pi on 3. That's what's happening. 2 graduations. So this dot here at 0, 2 is going to move 2 to the left. Going to our x-axis, the pi on 6, 0 is going to move across to negative pi on 6. Dot down the bottom moves across to your y-axis. This dot here moves across to the one previous, and then this one moves across to here. So now we're drawing our final curve. Again, it said just showing one complete cycle, so I don't have to keep going. I could if I wanted to. I would just have to keep following that pattern. Okay, so I could just keep going. If this said to go up to pi or 2 pi, we would just keep going and follow the pattern. So my red curve is y equals 2 cos 3x plus pi. Now let's look at one more that's going to be a little bit more complicated. Okay, it's a basic sine curve. So it looks like that. Amplitude is 1. Period is still 2 pi. There's nothing happening in front of that x. So my scale is going to be my pi onto pi, 3 pi onto 2 pi. And then I have a horizontal translation or phase shift. So you're going left pi on 3. So before I would say draw your graph, worry about your horizontal translation last, but you can't here because this pi on 3 doesn't match our scale for our x-axis. So what we need to do is we need to move each of these points that we found to the left pi on 3. So pi on 2 minus pi on 3, common denominator of 6. So it's going to be 3 pi on 6 minus 2 pi on 6, which is pi on 6. That's our first one. Pi minus pi on 3. Now, hopefully, one whole take away a pi on 3 is 2 pi on 3. 3 pi on 2 minus pi on 3 is going to be 9 pi on 6 minus 2 pi on 6, which is 7 pi on 6. And then our 2 pi minus pi on 3 is going to be 5 pi on 3. You can't see this, do it the long way. 6 pi on 3 minus pi on 3. Okay, so now we have our points that are going to go on our x-axis, and they're going to help us be able to do that translation. So draw your axes. Okay, so put in your y and your x. 1, 2, 3, 4, pi on 6, 2 pi on 3, 7 pi on 6, and 5 pi on 3. Your amplitude is 1. Draw in your dashed lines if you need to. It's a basic sine curve, so put in your key points. Join your dots, and you are done. Okay, so you've done your final curve in one step. Now, the reason why I don't do it this way for the previous ones when we draw the intermediate curve and then the phase shift is so you don't have to deal with the fractions and working out your new scale. Okay, because it is already set to the graduations that you have on your X scale, so it makes it easier.